Jet engines are incredible feats of contemporary engineering that provide power to almost all commercial airplanes and many military aircraft. They have transformed air travel by allowing aircraft to fly faster, higher, and further than they ever have before. Before we go into the details of how a jet engine works, let's take a moment to discuss why it is important and its historical relevance. Number 8. A short history of jet engines. What technology from ancient times was the basis for the development of contemporary jet propulsion? The evolution of jet propulsion is a testament to human ingenuity, marked by an unwavering pursuit of increased efficiency, speed, and technological dominance. While the Industrial Revolution introduced essential concepts like steam power and gas turbines, earlier concepts like Hero of Alexandria's Aeolipile suggested the potential of reactive forces. This continuous endeavor has led to the creation of sophisticated, high-performance jet engines that have revolutionized modern transportation. Ancient beginnings, the Aeolipile, and early concepts. Hero of Alexandria invented the Aeolipile in the 1st century AD, marking the beginning of the history of jet propulsion. This early contraption showed how jet propulsion works. Steam exiting via angled tubes created a spinning motion. Although the Aeolipile was mostly only a curiosity in ancient times, its functioning was the earliest known usage of reactive force, which would eventually be important for the development of contemporary propulsion systems. The Aeolipile, which has a basic construction, was an early example of jet engine principles and demonstrated the possibility of using force to create mechanical movement, steam power, and the Industrial Revolution. For hundreds of years following Hero of Alexandria's first experiments with jet propulsion, the idea of harnessing reactive forces for power remained mostly unused. The Industrial Revolution, on the other hand, sparked renewed interest with the invention of steam turbines and early internal combustion engines. These improvements in energy conversion provided a foundation for future developments. During this time, significant advancements in thermodynamics and materials science were made, enabling engineers to create engines that are more efficient and able to endure high temperatures and pressures. These improvements led to the creation of the gas turbine engine, which was a significant leap in propulsion technology and had an impact on a wide range of fields, including aviation and power production. The Jet Age, World War II, and the first jet engines. The need for jet engines during World War II led to their evolution from theoretical ideas to working technology. The Heinkel He-178, which was the first jet-powered aircraft in the world, took to the skies in 1939. This event marked the beginning of a new age in aviation. Sir Frank Whittle in Britain and Hans von Ohain in Germany were two important pioneers who separately created viable jet engines. Early 1930s doubts greeted Whittle's turbojet engine, but it ultimately emerged as a groundbreaking invention. At the same time, von Ohain's innovations were used to power Germany's combat aircraft, which showed the practical benefits of jet propulsion compared to conventional piston engines. After the war, countries realized that jet engine technology may change both military and civilian aviation. This led to fast improvements in the technology. Number 7. Jet engines. An introduction. In what way does Newton's third law provide power to the airplane you are flying on? A jet engine is a thermodynamic masterpiece that makes use of Newton's third law of motion, which says that for every action, there is an equal and opposite reaction. The engine produces forward thrust by pushing high-speed exhaust gases out the rear, which allows the aircraft to move forward. The Brayton cycle is a continuous process that guarantees effective energy conversion, and the engine runs on it. The process starts with isentropic compression, which is when the compressor compresses the incoming air, raising its pressure and temperature. Next, in constant pressure combustion, the combustor injects and burns fuel. This process releases energy while keeping the pressure constant. The high-temperature gases that are produced go through isentropic expansion as they go through the turbine and nozzle. During this process, they lose pressure and gain speed. Finally, the cycle is completed when the exhaust gases leave the engine, causing the airplane to move forward and releasing heat. Jet engines are very efficient and essential for contemporary aircraft because they can convert chemical energy into kinetic energy without any interruptions. Number 6. Parts of a jet engine. Did you know that the fan at the front of a jet engine does more than simply suck in air? Jet engines are complex devices that consist of several important parts, and each of these parts is essential for the engine to work well and efficiently. These components collaborate to handle the challenging conditions encountered during flight. Fan. At the front of the engine, the fan stands out as a large and prominent component. It is responsible for pulling in a significant amount of air. The air is divided into two streams. One stream goes into the engine core, where it is compressed and ignited. The second stream goes around the core, which provides extra thrust. This design is standard for turbofan engines, which are used in the majority of commercial airliners. The fan is usually constructed from modern lightweight materials like titanium or carbon composites. This ensures that it can withstand the high rotating speeds and the tremendous stresses that occur during flight. Compressor. The compressor is important because it increases the pressure of the air that comes in, which makes the air denser and better for combustion. The compressor comprises numerous stages of rotating blades and stationary vanes. As air moves through these steps, it is gradually compressed, which gets it. These steps gradually compress the air, preparing it for the combustion process. While still being fuel efficient, it is essential to have a compressor that is very efficient. Combustor. In the combustor, compressed air is combined with fuel and ignited, resulting in the production of a gas that is both high pressure and high temperature. This gas powers the turbine. In order to achieve full combustion and maximum engine efficiency, it is essential to have a well-designed combustor. It must also be able to tolerate severe temperatures, which regularly surpass 2000 degrees Celsius, while avoiding any structural damage to the engine components. Turbine. The turbine takes energy from the hot, expanding gases that come from the combustor. Sophisticated materials, including nickel-based superalloys, form the turbine blades. They use this energy to power the compressor and fan. These materials were selected because they can endure the severe temperatures and strains that occur during operation. Nozzle. The nozzle accelerates the exhaust gases as they exit the engine. It transforms the pressure of the gases into high-speed exhaust, which produces thrust that pushes the airplane forward. Variable nozzles are used in certain engines to change the flow of exhaust gases. This helps to improve the engine's performance under varied flying situations, such as during takeoff or cruising. A jet engine carefully builds every part to function under extreme conditions. This guarantees that the engine performs at its best, uses fuel efficiently, and is safe during flight. Number 5. The function of a jet engine. As air travels through a jet engine, what changes does it undergo? There are 5 distinct phases to a jet engine's operation. Step 1. Air intake. The process begins with air intake, during which the fan is essential for pulling in enormous amounts of air. Modern intake designs are designed to improve airflow, ensuring that it is smooth and stable as it enters the engine. This reduces drag, increases economy, and allows for smooth functioning at different speeds. Step 2. Compression. When air passes through the compressor, it is compressed to a fraction of its original volume by a succession of revolving blades and stationary vanes. This procedure greatly raises the air's pressure and temperature, which creates the perfect circumstances for the efficient combustion of fuel in the following step of the engine's functioning. Step 3. Burning. The combustor, which is an important part of the jet engine, receives the compressed air. In this method, gasoline is injected and ignited in a controlled manner, resulting in a powerful combustion reaction. This produces gases that are at a high temperature and high pressure, and that expand quickly. These expanding gases release a tremendous amount of energy, which powers the turbine and generates the thrust that is needed for propulsion. Step 4. Expansion and extraction of energy. The combustor produces high-temperature gases that travel through the turbine. The gases spin the turbine's carefully constructed blades at exceedingly high speeds. This circular motion takes energy from the gases. The turbine distributes this energy to the compressor and the fan at the front, which creates a self-sustaining engine cycle that allows for continuous operation. Step 5. Exhaust and thrust. The nozzle channels the high-pressure gases and speeds them up to an incredibly high velocity. These gases provide a strong thrust force as they leave the engine. This push successfully counteracts the drag exerted on the aircraft, allowing it to fly ahead with tremendous speed and efficiency. Number 4. Different kinds of jet engines. Why are turbofan engines the most often used engines in commercial aviation? There are many different kinds of jet engines, each designed for a unique purpose and performance needs. Turbojet engines. Turbojets are the most basic kind of jet engine. In a turbojet, all incoming air passes straight into the core, where it is compressed, ignited, and released at high speed. These engines are best suited for early military jets and supersonic aircraft, since they work most efficiently at high speeds and altitudes. However, they are not as fuel efficient and produce a lot of noise, which is why they are not as often used in today's commercial aviation. Turbofan engines. Turbofan engines are the most common kind of engine used in contemporary aviation, especially in commercial airliners. They have a high bypass ratio, which means that a considerable amount of the incoming air goes past the engine core and is directed around the engine by a fan. Turbofans are the best option for passenger planes for long-distance flights, since their design significantly increases fuel economy and decreases noise. Turboprop engines. Turboprop engines are a combination of a gas turbine and a propeller. They are very efficient at lower speeds and altitudes. These engines are often employed in regional aircraft, small airliners, and short-haul flights because they provide an excellent mix between performance and fuel economy. Engines ramjet and scramjet. Ramjet and scramjet engines are designed for supersonic and hypersonic flight. They take advantage of the aircraft's high speed to compress incoming air, which means that turbines or compressors are not necessary. These engines are used in experimental aircraft and military applications. They provide very high speeds, but are only suitable for high altitude or specialized flying situations. Number 3. New developments in jet engine technology. Is it possible for hybrid electric propulsion to change the future of aviation? Ongoing improvements in jet engine technology are aimed at increasing performance, efficiency, and sustainability in the aviation industry. The geared turbofan is one of the most important innovations. It employs a gearbox to adjust the relative speeds of the engine's fan and turbine. This design lowers engine noise, improves fuel economy, and helps to minimize operating expenses, all while preserving power. Another advance is the use of composite materials in the manufacturing of engines. Carbon fiber composites are lightweight but durable materials that assist in lowering the total weight of the engine. This improves fuel economy and performance without sacrificing strength or safety. In addition, hybrid electric propulsion systems integrate classical jet propulsion with electric motors in their development. This new technology might lead to cleaner and quieter airplanes by reducing the amount of fuel they use and the amount of carbon they emit. Finally, sustainable aviation fuels (SAFs) are made from renewable resources, including algae, agricultural waste, and other biomass. They are a more ecologically friendly option than traditional jet fuels. Sustainable aviation fuels (SAFs) may greatly reduce greenhouse gas emissions, and because they can be employed with little to no changes to current engines, they provide a quick way to lessen the environmental effect of flying. Number 2. The effects of jet engines on the environment. What steps is the aviation sector taking to address the problem of greenhouse gas emissions? Jet engines have transformed transportation throughout the world by allowing for quick and efficient travel. However, they are also a major source of greenhouse gas emissions, which contribute to climate change. The aviation sector is investing in sustainable technology to reduce its carbon footprint in order to address these environmental concerns. A major area of concentration is the development of fuel-efficient engines, with innovative designs being created to improve performance and reduce fuel consumption and emissions. Sustainable aviation fuels (SAFs) are made from renewable resources, such as agricultural waste, and are becoming more popular as a greener alternative to standard jet fuels. They provide a significant decrease in lifetime carbon emissions. In addition, new propulsion technologies, including hydrogen-powered and electric engines, are now being developed. These innovations are expected to revolutionize the aviation industry by allowing for cleaner skies and a sustainable future, while still providing the convenience and connection that air travel offers. Number 1. Maintenance of jet engines. What methods do sophisticated sensors use to anticipate and avoid jet engine malfunctions? The process of maintaining jet engines is very thorough and important, as it guarantees their safety, dependability, and best possible performance. To avoid any problems that might affect the engine's performance, it is essential to conduct regular inspections and maintenance. Visual inspections are one of the most important maintenance chores. They help to spot exterior damage, such as cracks, dents, or wear, and ensure that any obvious concerns are taken care of quickly. Non-destructive testing. NDT is essential for finding internal defects. It uses modern methods like ultrasound, X-rays, and magnetic particle testing to discover any vulnerabilities without taking the engine apart. Regular cleaning is just as vital, since it gets rid of dirt, pollutants, and residue from components, which helps keep everything running smoothly and reduces wear and tear. Component replacement guarantees that worn-out or damaged components are replaced before they cause a failure, which helps maintain long-term dependability. New technologies like predictive maintenance, which use sensors and real-time analytics, are changing the industry by enabling engineers to continually monitor engine health and fix problems before they become more serious. In conclusion, jet engines are remarkable technical accomplishments that have transformed transportation across the world, allowing for fast travel over seas and continents. They are the foundation of contemporary aviation, linking people, cultures, and economies in ways that have never been done before. The history of jet engines is a testament to the unyielding creativity of humankind. It ranges from ancient ideas, such as Hero of Alexandria's Iolipoli, to the sophisticated propulsion systems that we have today. The fundamental concepts of jet propulsion, which are based on Newton's third law of motion, have been improved over the course of centuries thanks to progress in the fields of thermodynamics, materials science, and aerodynamics. Modern jet engines are very efficient devices that can turn chemical energy into tremendous thrust with incredible accuracy. Jet propulsion is expected to become more sustainable and innovative in the future. The development of sustainable aviation fuels, SAFs, hybrid electric systems and hydrogen-powered engines is helping to lessen the environmental effect of aviation and is paving the path for cleaner, greener skies. Jet engines will continue to define and impact the future of transportation as technology improves. Don't forget to hit like, share and subscribe for more amazing content.